Yes, yes, of course. What? You can't read this? No, I'll zoom in. Before I read it, I'll zoom in. All right, guys. So we're going to read a paper called The Chain of Thought. This was a somewhat unexpected discovery. These were the early days of prompting. Look at the date, January 2023. Remember that one of the most popular chat bots, ChatGPT, had just come out in November prior to that. So very early on, Google was internally playing with some version of Gemini. So some folks at Google Research began to observe something quite interesting. And I don't think anyone expected that. This is the nature of these LLMs. They have all sorts of surprises to throw at us. The surprise they had was literally captured in the very first figure. That's why this paper is a very easy read. They did that, I suppose, with their own model, Palm 540 billion parameter model. And I'll just read the abstract and then it'll become easy to follow through. We explore how generating a chain of thought, a series of intermediate reasoning steps, significantly improves the ability of large language models to perform complex reasoning. In particular, we show how such reasoning abilities emerge naturally in sufficiently large language models via a simple method called chain of thoughts prompting, where a few chain of thought demonstrations are provided as exemplars in pointing. So let's unpack this big paragraph. A few demonstrations. A few demonstrations is reminiscent of which technique in prompt engineering? A few examples is called few shot, right? So they are using few shot. So let's unpack it like that, where a few chain of demonstrations are provided as exemplars. So obviously a few shot, it comes within the category of few shot. Now, what they show, now we do know that LLMs follow a neural scaling law. What does the neural scaling law say? That as you make the models bigger, as you train them with more data, and as you train them with more compute for more iterations, they in general tend to develop newer abilities. These are called emergent abilities. At one time, people thought they suddenly appear. Today, we know it's not like that. They appear gradually, but they do appear. New abilities begin to mushroom. Right? So, for example, in very small models, you may not be able to successively have these abilities. For example, the ability to do arithmetic and so forth. But in larger models, you see that they begin to do all of these things. So they're probably referring to that. So they say, in particular, we show how reasoning abilities emerge naturally in sufficiently large language models. So that's the emergence part of it in large models. And they show it via a simple method called chain of thought prompting. Then that's the thesis. Now they go on to say experiments on 3 large language models show that chain of thought prompting improves performance on a range of arithmetic, common sense, and symbolic reasoning tasks. So folks, 2023, remember January 2020, early days, people didn't quite expect these LLMs to be very good at arithmetic. They weren't. Actually, I remember when the ChatGPT initially came out, the first question a lot of people asked, in fact, I asked, why is 7 not a prime number? And it gave a pretty long answer explaining why 7 is not a prime number. Well, of course, it has wisened up since then. So it speaks to the fact that in those early days, it didn't have good reasoning, mathematical reasoning abilities. But things change, things improve. So arithmetic ability was something that people were focusing a lot on and seeing whether these machines can do arithmetic reasoning and symbolic reasoning tasks. So now this paper says the empirical gains can be striking. Using this method, the gains prompting method, the gains can be striking. For instance, prompting a Palm 540 billion with just 8 chain of thought exemplars achieves state-of-the-art accuracy on a general math benchmark of word problems, surpassing even fine-tuned GP3 with a verifier. GPT-3 was supposed to be much bigger, right? But it surpasses that. So the whole question is, what is this chain of thought prompting technique? Look on the left, it says model. A standard prompt would be, Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 balls. How many tennis balls does he have now? Right. And you are giving it an answer. The answer is 11. You ask it another question. The cafeteria has 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? The answer comes out to be 27, which happens to be wrong. Then you look at the answer. So what is the distinguishing feature? You gave examples. You were doing few shot learning on the left-hand side, right? You gave at least one example before you ask the next question. Guys, are we together? Right? You gave the answer. So therefore, it is few shot. But what is the difference between that and the next one? Same question, you see, you show it how to come upon the answer, 11. You break it up, you say Roger starts with 5 balls. 2 cans of 3 tennis balls each is 6 tennis balls. 5 plus 6 is 11. So the answer is 11. Right? So you didn't give a question and an answer. You gave it a method to come upon the answer, to think through. Am I making sense? Chain of thought. How do you come upon that? And when you do that, for the same question about the cafeteria has 23 apples, if they use 20 to make lunch and bought 6 more, how many apples do they have? Right? So now the machine imitates the reasoning. Right? It says the cafeteria has 23 apples originally. They used 20 to make lunch. So they had 23 minus 20 is equal to 3. They bought 6 more apples. So they have 3 plus 6 is equal to 9. The answer is 9. Are we together? Right? This looks correct. So this is the remarkable. Now you would say that, now do you notice, guys, that this was not a mathematical discovery? This was just a discovery of how to talk to an LLM. It's a prompting thing. It's a prompting technique. Right? That's what it is. And therein the power of prompting. If you just think back and realize a machine that couldn't do math correctly now is able to do math much better. I wouldn't say perfectly, but much better. Prakash. Mm-hmm. Yeah, you can give different wording, but so long as you explain the process. See, the point is, look at the one in yellow and look at the one in blue. In the yellow one, you give the answer. You don't explain the process. In the blue, you explain the process. Doesn't matter what language you use. So long as you explain the thinking process, the chain of thought, that's the difference. So, so what it is saying is, this particular prompting technique says that don't just do few shot learning. Show to the machine how you come up with the answer, how you're thinking. And that's why it's called chain of thought. It's as simple as that. And it has remarkable results, right? Look at this. Yeah. Yeah. If there is a question appears, yeah, then filling this answer varies, right? It varies from Prakash, I know where you're coming from. What I would do is, let's say that you're doing some form of RAG retrieval, and that you will ultimately feed into some SQL generation or something like that. Right? What I would do is, I would not. I would take the input. I would first try to determine what is it asking about. Is he asking about data, right? And so then what I would do is I would pass it through a prompt, which where the chain of thought is, you know, give a few examples that says you're trying to find out the person, let's say an employee with the highest salary. So you would put your chain of thought saying, for that, I should first find out what the employee table is. Then I should find out where the compensation table is. Then only I need a field where I can associate an employee to the compensation, right? And I need to aggregate over the months to get the annual comp. And then I need to figure out this. So if you write down the chain of thought for that there, and that is an example of how it needs to reason through. The moment you do that in your prompt, you'll see dramatically better answer because you are giving it examples. This becomes even more sort of obvious if you are in a very controlled environment. So, for example, if you're doing RAG upon a known schema, yeah, then not doing few short exemplars and not doing chain of thought, especially for complex tasks like this, like SQL generation, is practically a crime, right? You should be doing it. It's a no-brainer that you will decrease the error rate. You can get away generating in many situations the right SQL, but with the chain of thought, the results would be so much more reliable, isn't it? That's the point that is being made. Huh? So chain of thought was the first technique. This technique has gotten refined. It became the tree of thought and so on and so forth. Many, many things. The whole star o thought has become quite a small collection of techniques that have emerged over the years. Go ahead. Yeah. So how do I plug in this thing with a different prompts, right? This one prompt you showed that you have a particular explanation of mathematics or addition here. Yeah. Yeah, yeah. So what you typically do is, what I do is, I don't ever let the prompt go straight to an LLM or just pick one prompt. Whatever the user gives, the first thing we do in my system, like for the edutech system that you're building, we have a classifier. We have literally a neural network, which itself is a mixture of experts, whose only job is from the repository of prompts to pick the most appropriate prompts, examples, prompts and exemplars. And dynamically, we create the system prompt. Right? So you will learn all my tricks in this course. But the only question is, are you guys willing to put in the energy to build those things on your own? Because you realize that I just told you that just to determine how that your prompt now became dynamic and programmatic, and to build it, you need another neural network, a whole, right, mixture of experts whose entire job is just to find out what in the world is the user talking about and figuring out what is the relevant ones to pick from a library of templates and what are the appropriate examples to feed into those prompts, into the few short examples. Right? And that's how you get good results. And that's why I'm saying that, see, guys, getting the best out of a LLM is not as easy as people think. There's a reason why the results are so poor. So anyway, this is the big. So guys, if you see, the paper will go on, but I hope the results speak for themselves. The solve rate, if you take a model which is massive, fine-tuned GPT-3, you notice is giving you a result of 33% problems it can solve. Isn't it? The prior best was this. Palm standard is 18. Palm was doing much worse. Palm could solve only 18% of the problem. But when you gave it chain of thought prompting on those math problems, do you notice that it is now able to solve 57% of the problems, right? It's getting to passing grades practically, right? So this is, by the way, not the end. We will keep revisiting the GSM 8K. And by the time you're done with this course, you will have models, you will have techniques that solves, uh, that let's just say that has a much, much higher solve rate. Can you guess what the solve rate will become by the time we are done with this course? Hold on to your seats. You'll find out. So there is not that well. Yeah. So this plot is interesting, this figure 4. So quite often you can understand the paper once you know the main idea just by looking at the figures. So figure 2 is self-explanatory, right? It convinces you that chain of thought is a good thing, especially for math-like problems. Things that has to be reasoned step by step. You move forward, and this paragraph is worth reading. It says, chain of thought prompting has several attractive properties as an approach for facilitating reasoning in large language models. First, chain of thought in principle allows models to decompose multi-step problems into intermediate steps, which means that additional computation can be allocated to problems that require more reasoning steps. Second, a chain of thought provides an interpretable window into the behavior of the model, suggesting how it might have arrived at a particular answer and providing opportunities to debug when the reasoning path went wrong. So in other words, if you give chain of thought reasoning, it will also do chain of thought reasoning. It will show how it thought. You can look into it. Uh, Third, chain of thought reasoning can be used for tasks such as math, etc., and is potentially applicable to any task that human can solve with language. Finally, COT. So I'll just use the word COT now. Finally, COT reasoning can be readily elicited in sufficiently large, off-the-shelf language models simply by including examples of COT. Right. So this is it. Now here's an example of input chain of thought output, triplet for arithmetic, common sense, and symbolic reasoning benchmarks. Chain of thoughts are highlighted. So what it comes up with. So everywhere. So these are just examples. I'll skip it. This figure is important. Chain of thought prompting enables large language models to solve challenging math problems. Notably, chain of thought reasoning is an emergent ability. Remember, in those days, people realized that the neural scaling laws were there. Ability of increasing model scale. Prior best numbers are from blah, blah, blah. So you notice that if you take small models, then your solve rate with or without chain of thought remains pretty low. Look at for example, these numbers. They look somewhat low, isn't it? But as you scale the model, you see the chain of thought begins to do better. In GPT, for example, chain of thought has a dramatic improvement as you go to 175 billion parameter model. Palm also, it increases quite a bit, right? So there are all of these different benchmarks. In every case, you notice that yeah, 3.5, the phi 3.5, the small one. See, the answer to that is yes. Phi started with the research paper, textbooks is all you need. Right? Basically stating that instead of just blindly scaling the model, let's pay attention to the quality of the data. And textbooks are, of course, the highest quality text, very carefully written things, right? So they went with that, and progressively phi, phi 2, phi 3, these things have been coming up. Inherently, phis are very small models. And so you're competing against two opposing forces. The force in favor of phi would be the fact that it's trained on very good models. It has also benefited for the last 2 years of breakthroughs about large language models and transformers. Nevertheless, it is still small in size. At any scale, chain of thought gives you some benefit. At very small scale, the machine simply has no reasoning ability. So giving it examples doesn't help you. Whether it works with chain of thought works with Phi 3.5, I would say that just experiment and see. Pass it the same examples and see what happens. I haven't done that. I haven't played with 3.5. I'm curious about what happens myself. Yeah. Okay, nice. Try it out. Try it out. And so you can see there are studies after studies that show that, yes, chain of thought is one of the stronger factors that lead to success by far, right? So I won't go into it. Guys, if you understand what chain of thought is, the rest of it is just a rigorous academic proving ground that, yes, it works and to what degree it works, right? So with that, I'll conclude the reading of chain of thought. Associated, similar to this, is a tree of thought. So let's look into that other paper, tree of thought. Where am I? Trees of thought. And I may not do the whole of it. I'll just read the abstract because may I leave this as a reading exercise because we have to read the simulacra paper. Suffices to say that it amplifies the work of chain of thought. Right? 230, okay. Let me bring it in. Here we go. So what it says is that language models are increasingly being deployed for general purpose solving, general problem solving across a wide range of tasks, but are still confined to token level, left to right decision making processes during inference. A big sentence to say basically they are next token predictors. And this means they can fall short in tasks that require exploration, strategic look ahead, or where initial decisions play a pivotal role. To surmount these challenges, we introduce a new framework for language model inference, the tree of thought, which generalizes over the popular chain of thought approach to prompting language models and enables exploration over coherent units of thoughts that serve as intermediate steps towards problem solving. TOT allows LMs to perform deliberate decision making by considering multiple different reasoning paths and self-evaluating choices to decide the next course of action, as well as looking ahead or backtracking when necessary to make global choices. Our experiments show that TOT significantly enables language models' problem-solving abilities, blah, blah, blah. It does, in other words, it does well, right? So what does tree of thought do? What it does is, are you guys familiar with a maze, right? So how do you find the path in a maze? You do have some look ahead. You look ahead and say, oh, did I hit a wall? Yeah, I backtrack and then I try another path. So that's what it is going to do. What it does is it tries different reasoning paths and then it says which of them leads you to the self-consistent answer. And then it just picks that. I can go into the details of this, but I thought it would be, tell me if this looks straightforward enough that I'm trying to conserve time because I know we are getting, it's already 3:19. I want to do the other important paper. Can I just leave this as self-reading and put a quiz on it? So the quiz is already there. Yeah, I think it is in the, I have accidentally put it in the wrong place. It is in the, of course, LLM2. I'll move it to the right place. Frameworks and libraries. Yeah, so you have these quizzes. right? Multiple choice quizzes on these two papers. So you can do these quizzes. I'll move it to the prompt engineering, the art of the prompt course. I encourage you to do that. What I will do is I'll take a 5 minutes break and after that cover the simulacra paper from a prompt engineering perspective, not from an agent perspective. Okay? All right, guys, a 5 minutes break.